I lead our agriculture solutions and go-to-market strategy, which is essentially just working to bridge AWS services and infrastructure to address industry-specific use cases. And in this session today, we're going to be talking about how AI is really enhancing agronomic intelligence and decision making, and diving into some of the details and case studies with Josh Smith and Kyle Bridgeforth from Custom D and Caitlyn AI. As we're going through the presentation, if you have any questions, feel free to drop them in the chat, and we'll hold some time at the end to get to Q&A. So to kick us off, I just want to spend a few minutes providing some grounding in like the role of AWS and AWS infrastructure and services. We have a comprehensive and robust portfolio of services to power AI development. And at the heart of this is Amazon Bedrock, which is a platform for building generative AI applications and AI agents. More and more, we're seeing organizations begin to reimagine traditional workflows with agents. And there are many wonderful off-the-shelf solutions that can handle many common use cases, but competitive advantages often stem from automating the differentiated processes and leveraging proprietary data with custom agents and workflows. Bedrock provides a flexible platform that allows really anyone to build and orchestrate agents, and it includes built in a broad catalog of the leading models, the ability to really easily customize it with your own data, and built-in features that optimize for cost, latency, accuracy, and the like. Now, I want to emphasize the intentional design around safety and responsible AI best practices. Trust is paramount when it comes to technology solutions in agriculture, especially when that technology interfaces directly with growers. Bedrock guardrails provide customizable safeguards. For example, automated reasoning checks will minimize AI hallucinations and can deliver up to 99% verification accuracy. Now, we could spend a whole hour just scratching the surface on this topic, but today we really want to talk more about agriculture and agronomic use cases and share some examples of how customers are building agentic solutions in production today to drive real business value and outcomes. Syngenta here, for example, is a global crop inputs company that I'm sure many of you are familiar with. Syngenta developed CropWise AI using Amazon Bedrock and created a multi-agent system that aggregates extensive agriculture data sets, along with things like scouting notes and observations, in order to create personalized real-time recommendations throughout the growing season. This sort of enhanced decision-making workflow helps to improve sustainability through more precise product selection and input application, and resulted also in a 5% increase, up to 5% increase in crop yields. Now, in the post-event resources, I'll share an article and video if you're interested in diving into this case study a little bit more deeply. But what I want to share here is that these types of custom agentic solutions should not be limited to big corporations like Syngenta. And that's why I'm really excited to be working with Custom D and Caitlyn AI, who are tackling some of the challenges that are unique to the agriculture industry head on and making these technologies more accessible to organizations of all types and sizes. And so with that, I'd like to introduce you to my co-presenters today. We have Josh Smith, who is the Chief Revenue Officer at Caitlyn, with 12 years of experience working at the intersection of business and technology in many highly regulated industries. Josh has a unique combination of technical depth and strategic vision, and he's passionate about closing the gap between data potential and field level action. Now, joining Josh, we have Kyle Bridgeforth, who is head of US strategy at Caitlyn and has a deep background at the intersection of agriculture, policy, and technology. He's also a fifth generation farmer, so he brings on the ground agronomic experience and leadership to Caitlyn's mission. Kyle is also passionate about driving secure AI-powered innovation across global food systems. So with that, I'll go ahead and hand it over to Josh. If you want to go ahead and share your screen, Josh, I'll stop sharing mine.
Brilliant. Thanks, Patty. I will just get everything set up. So can you see my sort of intro slide there?
Yep, we're all good.
Excellent. All right, we'll kick things off then. Well, yeah, thanks, Patty, for the intro and for the opportunity to present today. And welcome, everybody. Kyle and I are very excited to be sharing some insights and a bit of our story and our journey of how we've been deploying AI-powered agricultural solutions in production. And today we'll be covering a couple of our case studies, sorry. A little bit around the importance of trust and guardrails and how we tackle that in practice. And then to sort of wrap up the webinar, we'll take a look into the future, which I think is actually the very near future, into where this technology is headed and look at the concept of what a digital agronomist might look like. You've already met the three of us, so I'll cycle on through. And there's the agenda I just mentioned. So we'll try and keep this to about 30 minutes or so. Hopefully we have some time for some Q&A at the end. As Patty mentioned, just feel free to drop any questions into the chat as we go, and we'll try and get to those at the end. So to kind of kick things off, I'd just like to give you a bit of an intro into who we are, what we've been doing, and some of our sort of learnings over the last couple of years of operation. So as you can tell, I'm from New Zealand, and we're headquartered in New Zealand. So we're a team of about 22, and we've actually been, a lot of us have been working together for a very long time, about 20 years in total, as Custom D. Custom D traditionally has been a software development company. We've built solutions for highly regulated industries, tech, fintech, as well as quite a few agricultural customers of ours. We do operate across New Zealand, Australia, and the US. And about 2 years ago, Caitlyn AI as a platform product was born out of Custom D. And hence we have Kyle, who's our US boots on the ground. But we do work very closely with AWS. We're an advanced tier partner. We've got our generative AI competency, and I think we're about to hopefully get our agentic competency. And we have a strategic collaboration agreement with AWS. So we partner and work very closely with AWS, who have supported us really well over the last couple of years of working in the AI space and in the agriculture sector. And just to give you, I guess, a bit of a story around our product, Caitlyn, and how it came to be. We'll dive a little bit deeper in a moment and some of the case studies that we've helped to create. But Caitlyn was really born out of a problem we were made aware of working with a very pioneering customer of ours about 2 years ago called the Foundation for Arable Research. So they're more or less down the road from us in Christchurch, New Zealand, and they're a research organisation heavily centered around um, supporting and representing the 3,000 to 4,000 arable crop farmers we have in New Zealand. And what we came to realize was that there's a real problem around research extension or getting knowledge into the hands of those that can use it to do things like drive practice change or improve outcomes. And then as we kind of looked more broadly outside New Zealand into Australia and now the US, and I think on a global scale, there's billions of dollars, probably more, invested into research each year and really valuable information. But very little of that actually reaches the end producer or the person who can make the most use of that. There's a lot of studies that get done that just end up either unpublished or just sitting on the shelf, or there's very scientific or highly technical reports. Um, and these producers, they often need to make high stakes decisions. The livelihoods depend on receiving accurate and relevant information that they can then act on. So that information needs to be easy to understand, localized, accurate, and applicable in practice. And a lot of that information is out there, but it's just difficult to find, get the time, the headspace to sit down, read through it all, and utilize. And Kyle, being a fifth generation farmer, I'm sure you have, some input on this and some experiences to share from your time out in the field.
Of course, and thank you, Josh. This is a challenge, not just in the field, but for every agricultural organization in the value chain. There's a lot of data. It's changing all the time. Um, in the US extension network, that data can often be redundant, but still difficult to find. So the issue comes when research is done over and over again. There's sometimes that same data is proprietary. Oftentimes, organizations that are adjacent to each other are doing the same projects. So the organization and the recall of that data is extremely important, especially in a system where margins are slim for farmers. Josh, as you mentioned, every decision counts. We have to Farmers have to do as much as possible to ensure you raise the highest yield, sell at the right time, and incorporate as much data as possible as available.
And so that's what really led us to develop Caitlyn as a platform. So at a very high level, Caitlyn is an agentic platform, and we've built it around high levels of accuracy, traceability, and security using the AWS stack. And very much in theme with this webinar, a lot of the work we've done has been about bringing together disparate, siloed, fragmented knowledge, bringing that in, and then creating a reasoning layer or the intelligence layer to produce trusted and verifiable answers within seconds. And in terms of our journey, so the last 2 years we've been in market and talking and working with many notable agricultural organizations across the industry and research institutes. And we did a bit of a tally up the other day, and I think we've had about 900 meetings and 52,000 minutes worth of interviews and conversations that we've been able to draw insights from, and roll back into events like today's webinar. And some of the things we learned at that time is, within the agriculture industry, data is not a problem. In fact, there's almost too much data. Making sense of it is the real challenge. We've come to learn that organizations are very concerned around protecting their own data and the IP that they produce. We were in San Francisco last week at the World Agri-Tech Summit, and a lot of the conversations revolved around people want to make use of AI, but they don't necessarily want to send all of their data out to an unknown source, or that they want to make sure that they've got protections in place so that their data remains theirs. We've done many speaking events of VocAg in Australia, helping build profile, and again, that's led to many great conversations within the industry of challenges that can be solved. And during that time, I mentioned already, we've built a good relationship with the AWS team who are helping support us in entry to new markets. And Kyle, I guess from your perspective, being based in the US, this doesn't seem to be an isolated problem within New Zealand or Australia. This seems to be a global problem, wouldn't you say?
Oh, that's exactly correct, Josh. It's not just New Zealand, it's not just the US, it's the entire world. It's the entire agricultural system. Uh, Finding Oftentimes one organization or one company will have their category of the agricultural supply chain and do research within it. But some of the best data and some of the best discoveries that we can find is when you combine data from one part of the value chain and another partner. Some of it may be proprietary. It may not have had any original intent of being combined together, and it could be from different years. But having access to the resources needed when the challenges rise to the surface is an important part of having something that's beneficial for farmers. That's a challenge that for some of the best discoveries we've had in the last few years has been overcome. So it could be genetics at one point, at one part for seed varieties to find a specific crop or a specific variety for a specific region, which then turns into an entire new entrance into a food system or a new protein basis for a local economy. All this data is there, and all this data is being created. We just need more tools to better organize and utilize it.
Cool. So I guess we'll jump through and take a look at a couple of case studies to showcase how we've been leveraging AI and this technology to basically provide that field level intelligence, or being that decision support system that's being used out there in the field. And one of our great case studies is the organization I mentioned before, which is the Foundation for Arable Research. And the question that came up for them was, how do you make over 30 years of agriculture research instantly accessible to growers? So for Foundation of Arable Research, they exist to provide education, support, and resources for New Zealand growers in the arable crop space. 12 major areas of research, thousands of reports over the last 30 years. A lot of them are internationally recognized. But the average report length was about 35 pages long, and most were written in quite technical language. Lots of charts and graphs and scientific terminology. And they were all sort of published but made available as PDFs on the website, so quite time consuming to find what you're looking for and then understand it and apply it. This is your slide, Kyle.
Yes, yes, got it right here. So growers oftentimes we need you need some context on what you're growing, your environment. Data is specifically is often region specific. So when you have a question that you're asking a platform, you want it to be something that applies to your local area. If you're in California, um, you don't want reference to a case study that happened in Alabama unless it very directly and specifically applies to your agronomic situation. So having a tool that is able to understand the context, understand your region, understand your history on the farm, what have you done in the past, what's your operational infrastructure on your farm is extremely important when someone's giving you recommendations. And you need a tool that can also speak your language. So having to ask an AI platform, can I have this specific soil sample at this specific date at this region, and I'm looking for these exact micronutrient levels and so on and so forth, is a very difficult task that is more in the scientific and R&D field than at a farmer level, someone who's putting this information into practice. So Caitlin can Caitlin can understand a question and normal, typical conversation, and it'll give you an answer in a very similar fashion. That's um that's really important when a farmer is asking questions about inputs or chemicals. You know, it could be you're using the brand name of a chemical instead of the active ingredient. Well, Caitlin has the ability to understand that question and give recommendations without the specific terminology being used. Also, an extremely important and valuable um, benefit of an organizational tool is that data comes in many different forms. It could be it could be in handwritten notes like we commonly have on our farm. We have written records from 10 years ago. Sometimes it's in spreadsheets. Sometimes it's in a digital format from some custom work that someone outside of our operation performed. Other times it's in a platform that we have on site, or occasionally it'll be data that was created by a third party, isn't accessible anymore, and having to track it down in a timely fashion when we need it just isn't possible. So having a tool that can instantly recall this information, collect it together, and provide it is essential when you're trying to make decisions in real time. But by far the most important is the accuracy. You want a tool, you want a platform that's giving you recommendations that are accurate and can showcase and explain that accuracy in case you want to dive deeper into the answer. You want to be able, just receiving a tank mix with X amount of this chemical at this rate during this amount of time and day. You may want to understand where the resource came from so you can better understand yourself or share it with your team. And all this combined together is really what farms need to be able to make confident decisions.
And so, as a solution, we worked with Foundation for Arable Research, and we white labeled and implemented Caitlyn as Ask for AI, which is embedded onto their site, and pretty, I guess, brave for the time. This is back in 2024, where a lot of this was still very, very new. They deployed this publicly, so if you're an arable crop farmer or researcher or anybody who wanted to tap into New Zealand-based arable crop farming knowledge, you could go to their website, ask any question you like of their knowledge base, and then get nice and concise, easy to understand answers. So We basically worked with them to bring in all of that knowledge, decades worth of information, tune an agent, and we'll cover in a bit some of the techniques we use to put that into practice, especially around the guardrails and trust. But as a result, huge increase in engagement and much faster and more relevant information being surfaced. And this information is just the information that Foundation for Arable Research put into their version of Caitlyn. So it doesn't go off to the web. It's a verified and trusted source of information. And more recently, at the end of last year, another case study, we worked with Beef and Lamb New Zealand. Very much the same concept. So unlocking $100 million worth of research for their sheep and beef farmers across New Zealand, which I think is about 6 or 7,000. And for them, they created an avatar called Bella, which is a sheepdog, and the idea is that scurries through the research and surfaces up the insights and answers. But for Beef and Lamb New Zealand, as well as a lot of I guess written and published content, they had over 700 videos, which webinars, podcasts, and so a lot of different file formats to bring in and to work with. For them as well, being able to interact in different languages, so having that multilingual capability was a huge plus, and I'll show you an example of this in a second. But for them, they did a really good job of promoting it, and there's nearly 1,000 questions asked alone on the first day, with some really good questions coming through. And to give an example of what this kind of looks like in a production setting, this is just a screen recording of, I guess, the old versus new way of interacting with information. So they have a knowledge hub on their website. You can do a typical keyword search, winter crop animal health issues, which will bring back about just over 700 results. And this information exists as articles, documents. I think there's Excel files, videos, webinars, but all sorts of different resources are available within that knowledge hub. So you need to be able to kind of have the time to get the information, find it, interpret it, then apply it. So we worked with Beef and Lamb to implement Bella, which is embedded on their site, fully white labeled. And to do a comparison, you can ask a question like, what is the biggest animal health issue for my animals on winter crop? And so what Caitlyn will do is it will first of all apply guardrails. Is this something I can ask? Is this information contained in the knowledge base? It'll look at the question and then expand it into different topics. So you can see here there's about 3 or 4 different topics it's expanded that into to get better coverage over the knowledge base. And then it will produce a response which matches the tone of voice and the presentation of the information that we've essentially asked the AI agent under the hood to present it in the format. So summary at the top, and then a deeper dive. And you'll notice that you've got those numbers appearing next to each paragraph. So those are the citations and the sources at the bottom. And the idea is that every single piece of content that is produced in this response is cited back to the source material. So in this case, the highlighted paragraph here from the source document is the exact piece of content that the agent retrieved in its search process and has formulated that into the response. And here we've got an example of a webinar. So it's actually scrubbed us to 4 minutes and 39 into the webinar. And they're actually, what they're talking about is answering the question that's been asked. So all of these sources are being brought together. It's all cited, you can verify it, and therefore you can trust it and apply it in practice. And just to mention, we'll touch on the multilingual aspect. These large language models, so we typically use the Anthropic Claude family of models. They have very good support for core languages and even some of the less common languages. So in this case, I can ask the exact same question in Spanish, but I could use many other languages. And the interesting concept here is that I'm asking in Spanish, it's going across an English knowledge base, and then it's being outputted again in Spanish. But you can mix and match different languages. And again, this will all be cited back to the source material. So again, this is a publicly accessible tool made available to sheep and beef farmers around New Zealand, highly accurate and contextually relevant to their particular scenarios, and you can interact through natural language, ask questions in your own way. We also have full analytics going through as well. So all questions that are asked are anonymized, but then you can see real-time insight into what people are asking about. You can see trends, and it helps them identify, it could be disease outbreaks or seasonal patterns and things like that. But you get to see real-time insights from questions that are being asked. So there are a couple of case studies of production grade AI being used out in the field by real producers and farmers. So it's good to touch on some of the trust and guardrail aspects that are really important to keep in mind when implementing these AI tools. Um, First of all, in terms of ensuring trust, and making sure that the answers are answers that people can rely on. Information needs to be relevant, it needs to be localized. One of the key techniques that we use, and this is sort of diving a little bit deeper, is all of the information that gets ingested into our platform. And this is a common technique across the board now. We actually extract metadata from that content. So that could be published dates, it could be author names, it could be the location of where a particular study or field trial was done. We pull out relevant specific pieces of information as metadata, which is actually used in the filtering. So if you ask a question, we're able to take the most recent, piece of research or the most relevant content from the overall knowledge base and serve that up from the metadata that's been extracted when we ingested them. Um, One of the probably most important aspects is what I showed before around citations, being able to trace the answer back to source material and verify where it comes from. Quite often, if you ask a question of, say, ChatGPT or some of these more generic tools, some of them have citations on web searches and things now, but quite often you don't actually know where that information has come from. So being able to verify that is incredibly important. And the other piece that we realized quite early on is that we often need to do we call it agent tuning. So if you're more technical, this is not tuning as in, fine tuning of a model in a technical sense. This is more tuning of the instructions that we give each agent that they need to follow, which can help really de-risk the possibility of hallucinations and increase accuracy. So an example of this would be layering in domain terminology, acronyms, uh, configuring tone of voice, being very clear on what the agent is allowed to do and what it's not allowed to do. And so that tuning process we put in place for each customer to make sure that the agent is acting and representing their organization in the most relevant way. And we evaluate that over time as a continuous operation so that if anything changes and some of the scores drop, we're able to adjust the tuning to bring the accuracy or whatever's dropped back in line with where we expect it to be. And then following on from that, we have guardrails. And so guardrails are really the safety frameworks, the policies, the mechanisms that constrain these AI models or agents, if you like, when they're working in operation. One of the things we learned really early on is that building for agriculture often means building for nuance. So being able to interpret a question and understand the meaning, especially when we realized early on that a lot of people started using these tools like Google searches. They were just putting in keywords and hitting go and hoping for the best. And over time, the behavior has shifted to asking more fully formed questions. But we had to implement techniques like asking clarifying questions if the agent wasn't able to fully understand what somebody was asking. But what we mean by guardrails is just having really clearly defined boundaries on what the agent can do. So there is, I'm sure many of you have heard the terminology prompting. So we have system prompts, which control kind of the core of what an agent might do. And that might be sort of a catch-all for, any sort of unsafe behavior that someone might try and make an agent do. But then we have the user prompts or the configurable prompts, which is around, you're acting for this organization. These are the things you can and can't do, domain terminology, anything that's relevant to the sort of domain that it operates in. And then on top of that, as I mentioned, security and IP and sovereignty is top of mind for a lot of organizations. So we've been working to implement, role-based access and permissions, making sure that, if somebody isn't allowed to access this area of knowledge but can access somewhere else, making sure that AI respects that and has an understanding of who can access what. We'll often deploy Caitlyn and I think quite a few people in the enterprise level are doing this now as well. Deploy Caitlyn into a dedicated cloud environment per customer, so they have almost a fully firewalled and walled garden, if you like, control over their data and what lives in that environment. And also through the use of Amazon Bedrock, the large language models that we interact with. So the Anthropic Claude, for example, um, Amazon Bedrock allows us to have that in escrow, which means that we're not sending information off directly to Anthropic or OpenAI directly. All of the requests and information is contained on the AWS network, so we have full control and visibility of where that goes. And of course, the benefit of working with a hyperscaler is that you can choose where these solutions are deployed. So, for customers in Australia, we'll deploy in Australia, typically Sydney, but in the US, there's multiple locations. There's also a location in New Zealand as well. But Kyle and I were talking earlier, and there's some interesting examples where guardrails really come into play, and it's really important to keep in mind when implementing AI in agriculture. So, Kyle, I'm not sure if you want to share a couple of those examples.
Absolutely. Having guardrails, having boundaries, having a platform that's prompting you and asking you questions to clarify it's an essential in a scale farming practice today. Some chemicals are legal in some states, illegal in others. Rates are often different from state to state, and it's important to understand that um, each farm isn't farming in a vacuum. I mean, there's conditions that change in real time. There's products that come on and off the market that can be mixed with others or require a certain adjuvant or surfactant or something to make the product actually work. So having some guardrails to ensure that everything is being planted, sprayed, harvested correctly is extremely important because you only receive one opportunity in a farming scenario. Once you spray it on the field, there's unfortunately no real way to take it off, and you need to ensure you're making the right decision by the time you enter the field. A prime example of
Oh,
prompts being
sorry.
needed. Well, I was just going to give one recent example that I experienced myself actually is when when a new seed variety that's often packaged together with um, agricultural inputs to put on with that new seed, the recommendation changes from region to region, and they have different application rates for a reason. So if you're using the Arizona seed and input recommendation, but you're in Florida or you're in Georgia or any other state along the East Coast, it will not work. And that's resources down the drain. That could be an entire season for that field down the drain. And having some guardrails to prevent that from happening is is essential.
And so in terms of how we construct, I guess our architecture for deploying these AI tools in production, um, excuse me, down at the bottom at level 4, if you like, we have the dedicated cloud environment, and this ensures, as I mentioned before, full security, full control of data within your own environment, and also, sovereignty, the choice of where that data is stored and located. The next level up, we leverage the AWS services for pretty much all of Caitlyn as a platform, but at the core of it is Amazon Bedrock. And so we use that for flexibility of a choice of models. So even though we tend to use Anthropic Claude Sonnet, and at the moment it's 4.6 for, I guess, our main sort of reasoning model, when you ask a question, there's many different steps that happen along the way. And so we use different models for different tasks in that kind of orchestration. So, for example, to classify whether the question's harmful or safe, we might use the Amazon Nova family of models, which are cheap and quick and efficient to run. And Bedrock gives us that flexibility of swapping out different models for different tasks. And more broadly, if you're looking to implement some of this technology yourself, it has guardrails that you can tap into um, with about 6 safeguard policies that you can leverage there. There's knowledge bases, and they've also got, I think, it was announced at the end of last year, Agent Core, which allows you to spin up agents and operate them in a safe and secure environment to create similar types of applications. So that's kind of our sort of foundation layer that we've implemented. Up from that, and where a lot of our kind of secret source and proprietary information lives is around, we call it the intelligence layer, but it's mostly around the intelligent document processing and everything that Caitlyn does is around that context engineering. So feeding a large language model the most relevant, accurate, precise context as possible to get the best outcome in return. And that's really hard to do at scale. It's often quite easy to do that with a couple of documents or at a much smaller scale. But one of our customers has just ingested, I think it was about 150,000 documents, and that's just for one of their knowledge bases. And so being able to surface up insights at that kind of scale gets quite tricky. And then at the very top, we have a delivery layer. So that's the interface you interact with. It's the white labeled interface I showed before. It's the API-driven side of things. And all those put together is really how we architect a solution like this in production. So just conscious of time. So we've sort of covered a bit of our story and some case studies and what we're running in production now, trust and guardrails. So in this section, we'd like to discuss, I guess, the concept of a digital agronomist and what the future might look like, and even the very near future, what's possible now.
Yeah.
Uh, so Kyle, being the resident agricultural expert, I might hand over to you for this slide.
Yeah, yeah, of course. And this is one of my favorite concepts, and one I'm really excited about this concept we're building out. It's the digital agronomist, which is not only beneficial for agronomists as a career, but farmers in the field. Oftentimes now, agronomist it it's not the lifelong career that it once was. Now it's often a right out of college, a few years into your career, before you move into the next level of a company. So at a farm level, where you're accustomed to having the same agronomist for decades. I up until a few years ago, we had the same agronomist my entire life. So it's changed a lot, and new agronomists don't have the same historical knowledge of decades of farming with the same operation. So you need a tool that can give you quick recall, instant access. Instead of remembering what happened on a field 10 years ago, you can see it digitally and make decisions from it. So it would be excellent for them to have a tool where they could not only see the details of the operation, but also have instant information on the greater industry as a whole. And being able to access that quickly, provide answers to farmers when they're asked in real time, instead of it being 2 days to give a recommendation, it might be 2 hours or 10 minutes. From a farmer level, this lets a farmer in a lot of ways be their own agronomist. You can see your information, you could have all the labels of all your inputs, um, and get recommendations and see data in front of you that you need to make decisions in real time. In a variable farming operation where conditions are changing often and your access to inputs are changing quickly. So this is a great tool not only for agronomists, also for farmers, and something that both could work off of together.
And to showcase this, we put together a bit of a proof of concept just to show what this could look like in practice, and I guess to provide a little bit of inspiration. So if I hit go on this, so this is designed as a digital agronomist tool. So in this case, this is for agronomists that's focused on corn and soybean plantations in central Iowa, weather, market information, season, some information being surfaced up in terms of notifications and planting windows and market opportunities, and some pre-suggested questions here. So one of those might be, should I plant today or should I wait? And what we're really illustrating here is something like, Caitlyn being able to tap into multiple sources of data. So that might be sensors in the field, it might be weather data, it might be commodity prices or supply chain. Bring that all together and being able to make highly targeted and accurate recommendations. So in this case, let's wait 5 to 7 days for the next warm window instead of planting today. And again, showing the evidence and sources of information where that comes from. Um, so in this case, it says, you've got about 12 days of buffer before yield penalties kick in. Do you want to push ahead? And in this case, I'll say I'll wait for the next window. Um, and then same process where, an agent would be able to tap into multiple sets of data, bring it all together, and then provide some sort of action off the back of that. And so, we're just sort of simulating some integrations here, some uploaded data sets, public research information, which is, of course, what we're working with now with Caitlyn, So this is really just to showcase, what could it look like if we're able to bring all of that information together for someone in a particular location with a particular crop. Geospatial information will obviously be a big one here as well, being able to map out accurately um, the field across the acreage, um, and then tying that all together, being able to do things like in this case again, build my in prescriptions, bringing that all together, and then showing some level of interactivity in the second when this loads. And I think it's actually fake loading, it's not real loading. But again, showing like a budget breakdown on the graph, or this is information that when it's at your fingers allows you to be highly efficient and plan and operate much faster. So this is definitely not a replacement for a real human out there, but it'll certainly make them a lot more effective and efficient if they have all of the surfaced up that they can then make decisions on in real time. Um, so I think with that, quickly run over some next steps. So I hope everyone found this useful in terms of what we've discussed today. Please do get in touch, even if you just want to have a conversation around what's happening in your world. We'd love to find out what's happening, out there, and different organizations, or some challenges that you're facing. If some of this is interesting and you'd like to explore some of this, we do run pilots, so they'll be available for attendees, and we do have some AWS funding that's available to offset some of the costs with that. And after this, we'll circulate the slides, and the recording will be made available. So feel free to share that with anyone you think would be interested. And Paddy, I might hand back to you for questions if we have any.
Absolutely. We've got a couple in the chat here, and we've got a couple minutes for questions. I can go a little long if others can go a little long, and anything we don't get to, we can reply and share out after the event. If anybody else has questions, feel free to put in the chat, or you can use the raise hand feature. I think we've got a small enough audience that we can go ahead and have you come on screen. So the first question here is about metadata, and I think this was from the questions from Francois. I was following the beef and lamb case study discussion. The question is, does the metadata have to exist separately from the documents to be ingested, or can you create metadata directly from the document text as you ingest it? And the context here is trying to gauge the dependency of the metadata having to exist already separately.
Yeah, that's a really great question. And the answer is actually we can do both. So one of our customers had pre-existing metadata that we're able to leverage, but for many others, as you mentioned, we extract that from the text from the documents as they get ingested. And so it's quite interesting how we do that. We actually use large language models predominantly to extract the information. And so we actually provide prompts or instructions to the large language models when they're ingesting documents on what to look for to pull out, those pieces of text and store them as metadata. Um, and as I mentioned, it's having that metadata on hand is really important for being able to, at a later stage, retrieve and filter content to get it highly accurate.
Great. Thanks, Josh. Uh,
Sorry, I'm just
Bunch of
going to,
questions
there we
kind
go.
of flowing
I
in
can see
here
everyone
at the
again.
end here. So trying to keep up with these, but let's take a few more. There's a question around cost and ROI. From my perspective, and I'll let you answer as well. It's so use case dependent, but we always work backwards from the goal and the outcome, and we implement proof of concept and proof of value before scaling a solution in any case. So happy to elaborate on that. As Josh said, get in touch. We can talk through your use case and the more kind of like box in the potential cost and ROI considerations. Josh, I don't know if there's anything you want to add to that.
Yeah, I would just mention that, across our customer base already, and, there's some that are in non-profit or industry good. There's some that are, science and research institutes, more emerging on the commercial side. And so they do have different objectives. And so the ROI can be measured in different ways. So as you said, Patty, we do tend to look at, what is the goal that we're looking to achieve, work backwards from that, and then, kind of work with that one-on-one to figure out what that looks like.
Mhm. So the next question is, I think if I'm interpreting this correctly, it's like how much of this could just be done with ChatGPT or say Copilot? and farmers can just use that directly versus building this custom solution. And I'll go
Yeah,
ahead and let you answer that question.
the reason why I'm smiling is that we get that question a lot, and it's a really good question. The guess the sort of general models and tools that are out there today are very powerful, and they're very accessible as well. What we've found is that, and we sort of mentioned this at the start, is that when in some cases, decisions, they're high stakes decisions, and sometimes, or quite often, livelihoods can depend on that, and you need to get the most accurate information for your specific scenario. We quite often take the outputs from something like Caitlyn that's trained or has ingested specific research or information compared to something like ChatGPT, which has a huge general training set. And the ChatGPT answer will often look very, it'll very confidently produce an answer that looks correct, but when we actually compare them side by side, they can be quite different. And so, to answer the second part of the question was, can anybody sort of replicate this? Um, one of the challenges we found when operating at scale across a lot of information is that the techniques that we've kind of deployed around the ingestion of information and the retrieval mechanisms and that context engineering is really kind of the secret to making this work at that level. Again, thinking about highly specialized and accurate information. At a small level, it generally works okay, but when you start to get into large scale production, things can fall apart quite quickly, and you go back to that scenario of getting inaccurate answers or hallucinations.
Thanks, Josh. The next question is actually three very thoughtful questions from Jacques, and for the sake of time, I think we might have to skip it, but I promise we'll follow up and share answers to the questions after the event. And yeah, I think this warrants a conversation. I think we'd be happy to get on a call with you to talk through some of those questions. And the last one we got in the chat here, I think we can go ahead and wrap it up on this one is, are the recommendations from the digital agronomist concept purely based on the knowledge base, like PDFs and literature, or can it tap into like analytics and models, like custom models and information to predict yield, for example, in order to optimize the recommended actions for growers?
Yeah, another great question. And we see this very much bring together many sources of information. So you'll have potentially a core knowledge repository or even public data sets that, so research data sets you can tap into. But where we're envisioning this going, and this is something that can be done almost right now or in the future, is bring together, it might be IoT sensors, weather data, commodity prices, to really kind of enrich, again, around that context engineering, bring that all together, feeding that to an agent that is able to then interpret and understand your intent and then produce a highly accurate answer based on your scenario. So I think the magic will be when you can combine all of those sets together. So a lot of the work we're doing at the moment is around that research or unstructured knowledge, but the next step or next phase is really connecting together all of those data sources. And yes, if you've got, I guess, the more traditional models like ML prediction models, being able to tap into that orchestrated through an agent, I think there's a lot of power and a lot of potential behind being able to do that.
Great. Yeah, I'm very excited about where we're going to go, even just in the coming months and year with integrating just these AI agents with robotics and physical AI and bringing satellite imagery to make real-time decisions, which obviously has to have a lot of analytics and modeling in the mix to generate the recommended actions. All right, so we're a bit over time already, so we'll go ahead and wrap up the Q&A there. Feel free to reach out if you have any additional questions. We'd be happy to chat, and we'll be sharing out the slides and the recording and some additional resources to everybody that's registered afterwards. And I see, Kyle, you've offered to stay on a bit longer to address the additional question there in the chat. So everybody else, feel free to disperse. Thank you again for joining.